to look at, I'm not going to do all the questions with you. If you don't practice this, guys, you're never going to learn it. For questions 4 and 6, I'm going to give you a minute, or about 3 or so minutes. I want you to try question 4 first. That is sine to the 4th power of x minus cosine to the 4th power of x divided by sine squared x over cosine squared x equal to 1. So I'm going to give you about 3 or so minutes. I honestly want you to try it. If you had this on a test or quiz, besides panicking, what would you do? What strategy would you use? Okay, so I want to hear from you guys. Besides panicking, what's the first thing you can do for this? Difference of squares, not difference of scares. You're going to use difference of squares for this. I would definitely start by using the left-hand side. That's the more complicated piece. Don't use 1 because it's just an uphill battle from there. Don't worry about it. So on this side over here, we're going to use difference of squares. And if you're like, wait, I don't understand how I'm supposed to use that for question 4. Okay, well, let me explain how this is possible. So for the aside work that you're going to use, this numerator is the same as if you had, for instance, y to the 4th power minus z to the 4th power. I'm just giving it 2 different variables because if I put x, you're going to get confused. So ignore this for now and just focus on this. If I asked you to use difference of squares here, can you square root y to the 4th power? Yeah, what do you get? Y squared. Okay, so that's going to be y squared plus something, y squared minus something. I'm going to put plus, minus. What's the square root of z to the 4th power? So you're going to have z squared here, z squared here. So you're going to do the same exact thing, but you just have sine and cosine that you're dealing with. So I'm going to move this over, and I'm going to use this exact same strategy for this guy here. So in the numerator, I'm going to rewrite this as sine squared x plus cosine squared x times sine squared x minus cosine squared x. And I'm going to divide all of that by sine squared x cosine squared x. And that's all going to equal 1. What can I do now? I can cancel. So double check to make sure you can. I know these 2 are being subtracted, these 2 are being added, but there is multiplication between both of those parentheses. You are multiplying both of those. So you can technically cancel this numerator and this denominator. That's going to leave me with, we'll have sine squared x plus cosine squared x equal to 1. What is sine squared x plus cosine squared x? Don't leave your answer like this, guys. And I want to remind you, you are working on one side of your equation at a time. You are not focusing on both sides. Notice how I haven't touched the 1 at all. So on this side of your equation, I'm going to rewrite my aside work again. Sine squared theta plus cosine squared theta is equal to 1. So I'm going to use this definition to go ahead and simplify. So I'm going to replace, where is it? Here it is. I'm going to replace the sine squared, cosine squared with that 1. So the 1 that I have here, I'm going to replace it. So we're going to have sine squared plus cosine squared, which is 1, equal to 1. You have to replace it, guys. Don't just leave it at this step and say, oh, Ms. Tapia, I'm done. No, you're not. You need to actually show me how does sine squared x plus cosine squared x equal 1. You have to show me that step. Give me a nod or shake. Is this okay? Okay. For question number 6. I'm going to give you another 3 minutes. I want you to try this one. If you need more space, guys, use the paper in your spiral or raise your hand and ask me for a sheet of paper. But I'm going to give you 3 minutes. Go. Okay, guys. I'm not going to go through all of it right now. I'm just going to help you guys with starting it off. We all agreed that the right-hand side is a little more complicated than the left. Okay, that's fine. So first thing that I would suggest doing, before you just start putting sine and cosine everywhere, is there any identities that you can use to try to simplify this? What? Secant. We can rewrite for our aside information that tangent squared x plus 1 is going to equal secant squared x. So we can replace this denominator, tangent squared x plus 1, with secant. We can just replace it. So we're going to rewrite this as 1 minus 2 cosine squared x equals, we'll have that numerator, over secant squared x. Okay, now what? Say it again. We can separate the fractions. You can either choose to keep the fractions together or separate. It'll still give you the same answer. So we can separate. We don't have to, but we can. So we'll have tangent squared x over secant squared x minus 1 over secant squared x. And remember, is it okay for me to have the same denominator here? Yeah, in order to subtract them, they have to have the same denominator. Okay, now what? What do you mean 1 over secant? Okay, so this is the same as cosine. Anything else that I could probably change, maybe over here? Okay, we could change tangent, and we can even change the secant down here to make it in terms of sine and cosine. So we're going to make this 1 over 2 cosine squared x equals, I'm going to put for the numerator, sine squared x over cosine squared x for that numerator. And then your denominator will have 1 over cosine squared x. And we're going to subtract that from, Gabriel just told me that the reciprocal property for this, or identity, will make this cosine squared x. What do you think I'm going to have you do with this first fraction? Keep, change, flip. So we're going to write this as 1 minus 2 cosine squared x equals, we're going to keep the numerator the same, change the division into multiplication, and then flip that fraction in the denominator. And you're going to subtract that cosine squared x. See if you can figure out what to do from here. I want to reiterate here, guys, you cannot touch both sides of the equation. If you start solving on the right-hand side, you need to finish solving on the right-hand side. What did you guys do at this point? What's the only thing you can do at this point once I rewrote it? Cancel out your cosines. Those are gone. Especially since you're multiplying both of these fractions, you can do that. So we're going to make this 1 minus 2 cosine squared x equals sine squared x minus cosine squared x. Now what? Replace sine with 1 minus cosine. Over here, in your Pythagorean identities that I gave you the first day we started talking about this, you have sine squared theta plus cosine squared theta equals 1. Guys, do not try to create your own math. You cannot replace sine squared x minus cosine squared x with negative 1 just to make it fun. You can't do it. So you need to take sine squared x minus or plus cosine squared x equal to 1. I need to replace just for cosine. If I can just replace for cosine, I'll have cosine in my answer. Because remember, you're trying to get this right side to look like the left. So if I can just get another cosine over here, I will have 2 cosines. So in this equation, guys, all you need to do if you're going to replace the sine is subtract cosine on each side. So we'll have sine squared x equals 1 minus cosine squared x. Quick question. Does this sign match with this sign? Oh, cool. Let's take what's behind it and plug it in. We're going to take that 1 minus cosine. Whoops, let me actually make that a 1. We'll have 1 minus cosine squared x minus that other cosine squared x. I'm putting that in parentheses mainly so you don't forget it and you don't lose it. Do I need that parentheses around it? No, I'm not distributing anything, so we'll rewrite it. What can I do from here? Okay, but when you combine both of these, what do they turn into? Not just because it's here, but because when you actually combine these, this is like negative x minus x. You can just combine both of those. So negative x minus x will turn into negative 2x, which is what we're looking for here. So cosine squared x equals 1 minus 2 cosine squared x, because you have 2 of them. I'm telling you now, guys, if you don't practice this concept, you're not going to be able to understand it. You have to commit the time to actually learn it. I want to bring your attention to something that's on the back page. You see this? Yeah, you guys just did that. So all of the work that you just did, it might be helpful to keep that in mind if you choose to do question 10 later on. All of the rest of these questions, guys, I have the answer key worked out for every single one of these questions with all the steps that I did. So if you have questions from anything on this page, refer to my answer key.